Hello, Math Jedi in training. This is Mr. Smith, and I'm here to talk to you a little bit about the Pythagorean Theorem. The what? The Pythagorean Theorem. The huh? The Pythagorean Theorem. I'll get into the words in a little while, explain why it's called that. But before I do, I have a quick question. I was wondering if you knew what happened to the plant in math class. Hmm. It grew square roots. What? What was that bad? All right, let's move on. So the first couple of examples today are right here. Strange little picture. Do you see the three squares over here on number one and on number two? Do you see the three squares? What's a little trick here is, do you see the right triangle right in the middle? There's a right triangle there and a right triangle there. I'll explain why the picture's set up that way in just a sec, but the important thing to realize is that in this right triangle in question number one, the two legs are 5 and 12 centimeters long. Notice the two legs form an L shape because of the right angle there. And the hypotenuse is 13 centimeters. The hypotenuse is always the longest side in a right triangle. It literally means stretched out, sort of like a hyperextended muscle. It got stretched. So hypotenuse is the longest stretched out side. In this triangle over here, this L shape, those are the legs. They are the shorter sides. They are 3 inches and 4 inches. The longest side, the hypotenuse, is 5 inches. And we're going to do something interesting with these and sort of to show you why the Pythagorean theorem works. So we're going to find the areas of the squares. So forget the triangle just for a sec. Going to find the area of the blue, the pink, and the green square for number one. And then for number two, same thing. So let's go ahead and do that. Take a look over here. So in example one, we're going to do the area of square A. Square A is a 5 by 5 square. So we're literally just going to do 5 times 5, and that's 25. And since it's area, there's square centimeters, not just centimeters. And then for square B, that's a 12 by 12. So we're going to do 12 times 12 and get 144 square centimeters. And then square C is a 13 by 13. So we're going to do 13 times itself. Here we go. And that's 169 square centimeters. All right. But why? You'll find out. Be patient. All right. So square A, same down here. We'll do 3 times 3. So that gives me 9. For square B is a 4 by 4. So it's 16. And square C is a 5 by 5, which is 25. And these, of course, are all square units. In this case, square inches. Square inches, square inches, square inches. All right, and here's the moment of realization. Did you notice that if you take these two numbers and add them up, you get that one? If you take the sum of the squares of the two shorter sides, otherwise known as the legs, you get the square of the longest side, known as the hypotenuse. And that is essentially the Pythagorean theorem, that a squared plus b squared equals c squared. And in geometry, we can use that to apply to right triangles and find out a couple things. First of all, we could find out if a triangle truly is a right triangle. And in those examples, you're just going to plug in the three numbers and you're going to test it out as if you're doing a check, an algebraic check. We could also use the formula to find the length of an unknown side in a right triangle. So we're going to do that right now. Over 2,500 years ago, a Greek mathematician named Pythagoras developed a proof that the relationship between the hypotenuse and the legs is true for all right angles. What did I just say? I just said this. I said it in words. A squared plus B squared equals C squared. If A and B are the legs, otherwise known as the shorter sides of the triangle, C is the hypotenuse. In the formula, the C always goes by itself. The A and the B get added together, A squared and the B squared get added together, and then the C squared is by itself in the formula. Quick way to find the hypotenuse is that it's always across from the right angle. And something that I like to do that's kind of fun is if you turn that right angle box into an arrowhead, it always points at the hypotenuse. Let me show you what I'm talking about. So here's the right angle box, but look, think of that as an arrow. And that arrow points right towards the hypotenuse. All right, so that's a quick way to find the hypotenuse. And that's the formula. And look at that handsome fella. That's Pythagoras. I think he copied his beard from me, but, well, I guess it's in reverse. But whatever. He was a little older than me. When Pythagoras developed his theorem, he only used it with right triangles because it doesn't apply to any other type of triangle. And we label the right triangle with letters A, B, and C. A and B are the legs, and the longest side is called the hypotenuse. And it's located across from the right angles. That's all the basics. Let's get to work, people. First thing you're always going to do is write down the formula. A squared plus B squared equals C squared. Always write it down so you have it right in front of you. I also suggest strongly that off to the side somewhere you identify what A is, what B is, and what C is. So in this first triangle, notice that they're all provided. There's nothing missing. The A and the B are the legs. The hypotenuse is right here. The legs are interchangeable. You could put 12 as A and 16 as B, or you could tell me 16 is A and 12 is B. It doesn't matter. It's the same thing. If you want to go way easy, go small, medium, large. Go small, medium, large. Always works. Little trick. So small, medium, large. So now we'll go back to the formula and plug it all in. So 12 to the second power plus 16 to the second power is equal to 18 to the second power. And then you get out your handy-dandy calculator if you need it. So 144, that's 12 squared. Then you look up 16 squared. You push those buttons if you need to. 16 times 16 is 256. And according to this formula, that should be equal to 18 times 18, which is 324. Now, this is where we're going to test it out and see if it's true. What is 144 plus 256? What is it, huh? What is it? Is it 324? No! It is 400. That's not equal to 324, which tells us that that is not a right triangle. The answer is no, it's not. So this right here is a falsehood. It's not a right triangle. You know, if this was math class, I would have yelled a long time ago about turning your phones off in class. So I'm going to do the same thing right now because that just keeps beeping. All right. Next, samesies. We're going to do the same thing to start out. The formula is A squared plus B squared equals C squared. We should identify the three sides, A, B, and C, but they're not these numbers anymore, so I'll get rid of those. Right now, we are dealing with whoa, that was crazy. We're dealing with a 15 centimeter leg, an 8 centimeter leg, 17 centimeter leg. So we're going to go small, medium, large. We're going to go, whoa, my gosh, it keeps happening. Ready? So just keeping you awake. 8, 15, 17. So you pluggy in. You pluggy. it would be 8 squared plus 15 squared. Plug it in, plug it in. There we go. And this one is 17 squared. I wonder if it's going to work this time. 8 squared. Do it. 8 times 8. Do it now. 64. Good. Very good. And then 15 times 15. Come on, you know that one. You know it. You don't? It's okay. Just go to the calculator. 224. 225. There you go. And then 17 times 17. Come on. What do you think? 17 times 17 is 289. And this is the moment of truth or falsehood. Add those together. 64 plus 225 is, in fact, 289. Samesies, we have twinning, which means we have a right triangle. So this is fine. And we say, yes, it's a right triangle. Yes. All right, good. Nexties. So to determine if these are the right triangle, you would do a squared plus b squared equals c squared. Okay. Here's your A. Here's your B. Here's your C. Here's your A. Here's your B. Here's your C. Small, medium, large. Okay. So plug it in. 6 squared plus 8 squared equals 10 squared. See what happens. 6 times 6 is 36. 8 times 8. Drum roll, please. 64. 10 times 10. Hundo. Okay. So add them. And this is, again, the moment of truth. Is 36 plus 64 100? Is it? Is it? Is it? Yeah, it is. So hundo, twinning. Yes, it's a right triangle. Okay, for this one, I'm going to clone my formula. Use it over here. All right. I already identified the A, B, and C. So 9 squared plus 12 squared equals 16 squared. Test it out. 81 plus a 144. That's just 12 times 12. And then 16 times 16 is 256. Now, hold on a second. I don't think this is going to work. 81 plus 144. 225? Oh my God, what a liar. It's not a right triangle. It's something else. It's like obtuse or acute or something. No, 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 no. Okay, good. Now, next application. We can use that formula, that beautiful formula, A, B, C, easy as 1, 2, 3. Here we go. To find missing sides. In this example, look where the question mark is. Is that a leg or a hypotenuse? So important to know that ahead of time. I see the right angle. It's pointing to the hypotenuse. So this is the hypotenuse, which means that it ain't A, it ain't B, it is C. These guys, I don't care which one you call which. One's A, one's B. I like going small, medium, large. Just keeps it simple. So let's do that. So 7 squared. I'm going to make that my A. And this my B. So 7 squared plus 24 squared equals, now this time we don't know C, so it stays the letter C. We don't know it. It's algebra, so it's a variable. 7 squared is 7 times 7. 24 squared, oh my gosh. Hit those buttons if you need to. 24 times 24, 576. And that's equal to c squared. And then you add these up. So 49 plus 576 is 625. So what? Does that mean c is equal to 625? No! C squared is equal to 625. So what you need to do, now if you don't have your calculator home, interesting fact, turn that phone sideways and you have all new buttons that you didn't know about before. So you do the square root of 625. The square root button looks like a little check mark. And it's important that depending on the calculator or phone you're using, you're probably going to hit 625 first and then the square root button. But it turns out that when you square root 625, you get c equals 25. That's the length of the hypotenuse in inches. So this is 25 inches. Let's do it again. There's the formula. But wait, there's no picture. I need a picture. No, you don't. It's okay. I mean, if you really want to draw a picture, draw a picture. But look at the directions. They're telling you to find the length of the hypotenuse. How do two hypotenuses greet each other? They say, hi, hypotenuse. Stop it, Mr. Smith. Just do the math, will you? All right, fine. That means the hypotenuse is missing. So that's the C. And let's make this the A and the B because we're going small, medium, large. So 5 squared plus 9 squared equals C squared. Keep it going. That's 25 plus 81 equals C squared. I don't know what happened to that plus sign. It went rogue. It's plus. There we go. So this is 106. Oh no, this might be a strange number. Let me see. C squared. All right, so like what? We got to square root that. Square root of 106. Square root of 106. All right, go to the calculator. Type in 106. Find that square root button. Oh my God, lots of crazy numbers. 10.295630. All right, hold on. 10. I'm getting 10.295630. I'm getting really tired writing. What do I really have to write everything? Oh, wait. No, I don't have to write everything. It says, if necessary, round answers to the nearest 10th. Okay, cool. So, nearest 10th. That would be this spot right here. And then next to the 2, next to the 10th spot and the 100th spot, I see a 9, which is going to bounce that 2 up to a 3. So I don't need any of this junk. Bye-bye, bye-bye. Just remember that 9 bounces the 2 up to a 3. So we're making 10 and 3 tenths. Final answer. And there's centimeters. Dunzo. All right, good. Next, you can do the same thing, but now we're going to find the missing leggy. So in each of the right triangles below, find the lengths of the missing leg. Only one leg. So, but I don't understand. I'm confused. This looks like, is the hypotenuse missing? It's the last one, but it says the leg is missing. All right, directions. Got to follow the directions. If the missing leg is this, that means that we're going to go like A, and we're going to go like B, which means this has got to be C because it's longer than that one. So we're going to go through, write down the formula. A squared plus B squared equals C squared. The smaller one of these has got to be a leg. So we go 3 squared. And we're looking for the other leg. So we'll make that the B. Could have made it the A. That's fine too. It's fine. And then 18 squared. Good. So this is 9 plus B squared. Oh, the variable's in a weird place. It's okay. It's okay. Calm down. Okay, 18 times 18 is 324. Oh, wait a minute. It looks like we're going to have to do a little algebra. So, 9 plus B squared. That means we have to get rid of the 9, do inverse operations, subtract it out. Boom. Oh, and this is where we needed to like Remember, you split the equation down the middle. Right. Okay, good. And then we go like this. So now b squared is equal to, I'm going to figure out 324 minus 9. And 324 minus 9 is equal to 315. That doesn't look like it's going to be a nice, clean whole number square root. I think it's going to be a decimal. Let's find out. So square root, b equals. All right, so 315, hit that square root button. Oh gosh, oh gosh. The calculator just vomited numbers at me. Okay, 17.7482. I'm going to write down some. 17.74823. I'm getting dizzy. Oh, wait. But it said, oh, look. If necessary, round answers to the nearest 10th. Yippee! So, okay, nearest 10th, 17 point. Here's the 10th spot right there. I look to the right. That's a little number. So 7 stays 7. So take your eraser and go bye-bye, 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 bye-bye. Stay 7. And it's going to be in feet. Keep those units the same. Last example. Samesies with the formula. You put this over here. Identify. Oh, this one has a picture. That's so nice. Look, shorty, long. And also notice the arrow is pointing to the hypotenuse. So that's the C. So identify right off the bat that this is C. A and B, I don't care which is which. Let's, just for funsies, let's call this the missing one. I don't know if it's smallest or medium. It doesn't matter. This will be the 12. This will be the 15, equals 15. Figure it all out. What's 12 times 12? And what's 15 times 15? Huh? Do it. Do it. This is a 144. This is a 225. And that's all equal to, so 225 equals 144 plus a squared. And we got to do the algebra stuff again. We're going to do some algebra. Minus 144 on both sides. Minus 144 on both sides. Here we go. So that means a squared is equal to, yes, I'm doing a video. Hold on one second. That's Jonah. That's my son. So ready? 225 minus 144. Say hi, Jonah.
Hi.
Minus 144 equals 81. Okay.
And then we go in the bomb shelter?
Oh, one sec. Okay, good. And then we do square root. And we do square root. And then a equals 9. Yeah, you heard that question. He asked if we want to go to the bomb shelter. And I said yes. It's an interesting part of my house.
Wait, we can?
Maybe later. We'll talk about it.
Oh, come on.
We'll find out. Okay, good. So 9 is equal to, this is what the Smiths do on Monday night or something. I don't know. So we do square root. 81 square rooted is 9. It's centimeters. So we keep it as centimeters. And that is that. So we found the missing side is 9 centimeters. We used the Pythagorean Theorem, and we did it. It's great. Here are 5 great examples for you guys to do for practice. And I look forward to seeing all of your answers. And you can do great with these. Keep in mind that when they have words and no picture, you either want to maybe draw yourself a picture or identify right away what that A, B, and C is. So I noticed the hypotenuse is missing in this one here. So that's got to be the C. Okay, good. Just keep that kind of stuff in mind. But go right away by writing down the formula, identify A, B, and C, and do it. Show all your work, please. Write down the units at the end, and may the math be with you. Have a great day. Bye-bye.